the sub-team leaders who make sure that the sub-teams are doing their weekly agendas and also communicating amongst each other. So now we're going to have locking, and Tyler will talk about that.
Thank you, Tim. The lock designing team's main focus is to create an unprecedented lock that can be applied to our bike sharing system. In order to create a lock that would be able to compete with existing locks and incorporate our electronic components, we needed to test them to see what we were up against. We plan to do testing on 3 different types of locks: the U-lock, the cable lock, and the border lock. In order to do this testing, we needed to make testing fixtures. Here are a couple of pictures of our team members at the Pearls Lab at the University of Maryland milling these testing fixtures. We plan to be done with testing by the end of the semester. Since the University of Maryland's preferred bike lock is the U-lock, our locks are very comparable to its design. The first design is a loop lock concept that we are still working on. The lock would be made out of steel. The red half has a longer shaft, which the yellow half rotates around, creating a loop. The locking mechanism has tumblers somewhat similar to that of a doorknob. The loop lock is the lock that we modeled on the bike up front. Our second design is a modified U-lock concept. The design is similar to that of U-lock, with a cable attachment on the side in order to prevent the removal of the top part of the lock and allow for more flexibility when locking. The lock would also be made out of steel. Depending on which lock we decide is most sensible for our system, we plan on applying for a provisional patent for that design. The first step in designing these locks was to create a computer-aided design model. The CAD model was helpful because it gave us better perspective on how the lock would work, move, and be machined. However, computer representations are still very limited. We used this CAD model to create 3D prints of our design. This is how we actually got to test how practical the design was. After printing our first 2 designs for the loop lock, the blue and the gray models, we realized that they were not sensible for our system because both of them had their own flaws. 3D printing saved us thousands of dollars, whereas if we had the locks built right away, because we could change serious flaws for very low cost. In the coming up year, we need to finalize which lock we are going to use and get it machined so we can do testing to compare our locks to the existing locks. We also need to come up with a way to house the electronic components that the 2 sub-teams are going to talk about. Now here's Peter to talk about access control team.
Thank you, Tyler. Access control team's purpose was to give users access to their bikes with 3 parts in mind: maximize security, maintain user convenience, and minimize power consumption. So some access control methods that we were considering were swiping, text to unlock, password combination unlocks, Bluetooth, and NFC, and of those, we chose NFC. NFC is a near-field communications. It's the same technology that you would use on a metro station with the smart trip cards. It is a type of RFID or radio frequency identification. It is very readily available in open source code and products with stackables for Arduinos. Currently, we have 3 stackables, Adafruit, Seed, and NFC 2.0 that we are using and testing. We also have all open source code modified for our purposes. On the figure, you can see how our system will work. We have the NFC reader that the user will tap their card to. It will send the identification to the Arduino, which will encrypt your identification, send that information over to the Zigbee, which will then send that over to a network. Some security concerns that we had were 2 mainly: man in the middle and eavesdropping, both of which would intercept the identification of the user and would make it useless. So we also do store certain data onto the bike, which we were also concerned with because if the bike were ever to be stolen, that sensitive data will be in the hands of someone that we wouldn't know. The security measures we took was that innately NFC is very secure because the reading distance of the NFC goes from 5 to 10 centimeters. So if anyone were to try to intercept any communications, they would have to be within that reading range, or they would need very expensive equipment. Also, we have very limited data stored, so we're only storing one person's identification, the last user. So we would, if the bike were ever to be stolen, we would only have one user that was compromised. We're also encrypting every user's identification. Sorry, it's been time. So we would be encrypting every user's identification in order to maximize security. Some future works that we have is to further develop a more robust encryption algorithm, manufacture our own microprocessor and reader so that we can scale down the electronics and size down the housing for the lock, and more efficiently communicate with the XB. Next, Kyle will be talking to you about the geolocation.
Thanks, Peter.
So our team was in charge of communication. Somebody had a great idea, let's put bikes everywhere where people want to use them. From a technical standpoint, this means we have bikes everywhere, and we have to figure out where they are, when people break them, we have to keep track of that. So we have bikes everywhere, and they've got local data on them. So who's riding them, where they are, and what we're going to do is transfer that data wirelessly. So we work kind of like Wi-Fi. We use what's called the Zigbee microprocessor, which releases an RF signal that can be transmitted wirelessly. So we have one on each bike, and then several throughout campus. So each bike shares your data to the nearest router, and then the routers pass it on until it gets to a special router that has an internet connection. From there, we can put it to our website and do something useful with it, and show you visualizations from, as the user, finding the nearest bike, to the mechanic to finding the first bike they have to fix. So choosing to build our own wireless system is quite a hurdle, and we did it for a couple reasons. Our first inclination to approach this was to start with, let's take a cell phone and take the parts out of it, so SIM card and GPS. What we found with that was, like all cell phone bills, it gets really expensive, and the technology itself is expensive on its own. So we tried to find a new way to do it, and through Zigbee, this allowed us to build a single system that could work for no matter how many bikes we had, and would scale up readily. It also allowed us to triangulate each bike's position, so we could throw the GPS out. From there, we needed to figure out how to show the data. And if we're dealing with 250 bikes talking to us every 3 seconds, like you can see how needy they get. And we want to show it in a way that's really visual and translate this data without any loss. So we chose the Meteor framework, which does a lot of the automation and the boring stuff for us. And it's the way everything's going to be going in the future, so we wanted to pioneer it. Currently, we have 3 separate parts working. We have the Zigbee network. We've started to build it and test with it. We're able to pass data from that controller to the internet, and then we're able to show like some data we put in there. And so our biggest challenge is getting those things to talk together, and as we scale up to do some of our testing. Now I'm going to pass it over to Libby to talk about how this could be a business.
Thanks, Kyle. So the business team, as a business team, our job is to focus on what the user wants so that our bike share and our locking design can accurately reflect the needs of the user. So last spring, we were awarded $4,000 from the University of Maryland Sustainability Fund, and this was really, really helpful in allowing us to actually start testing because we could buy things, and so in the fall, we reapplied. And we're always looking for new opportunities, so we are looking at the Venture Well grant, which is more business-focused. So this is an overview of our budget. As you can see, we've already spent $2,000, and we're planning on spending another $6,000. And so this money goes towards the bicycles, the locks, like making the locks, the geolocation things, and the access control things. So, of course, we want to apply this to the University of Maryland campus. And after we integrate it on campus, we'd like to expand it to other college campuses. And so at least on the University of Maryland campus, we'd like to call it Red Bar. Because when you don't have time in between 2 classes, on your schedule, it has a little red bar. And so we'd like to get you through that. So we're also looking at other college bike shares. And so right now our system is unlike anything that's currently available. So we have to make our pricing structure very competitive with these other college bike shares, but also affordable enough for students to actually use. So now we're looking at maybe paying by the year, paying by the month, paying by the season, or paying by day. And of course, we're also looking at other college bike shares to determine the number of potential users that we would have, and also how many bikes are needed to support this number. So in the spring, we're planning on having focus groups, and right now we're in the process of getting IRB approval for this. And the purpose of these focus groups is to gauge current interest and understanding of bike shares in general. And so most importantly, we really want to get feedback on our web application and our lock design, because those are 2 things that we really, really want student input on. And so now I'm going to pass it off to Emily to wrap things up.
Thank you, Libby. So as you can see, all of the different sub-teams are kind of coming to the end of the prototyping stage of the design process. We have the locking team that has finished doing prototyping using 3D printed models and is finalizing their testing in order to make the ultimate decisions for the physical design of the lock. We have the access control team that has a fully operational RFID reader using commercially available software, but is working on downsizing those components. The geolocation team has a web application with quite a bit of functionality and is working on building up the Zigbee network so we can identify where all the bikes are located. Finally, we have the business team that has filed for the necessary permissions so that we can hold a focus group in the spring, and is working towards getting together the payment and branding scheme that will be presented to the participants in the focus group. Now, all of this is we are doing with an eye to our ultimate objectives, which will come in 2 stages. The first is a 2-bicycle bike share system to be implemented in spring of 2015. From there, after we work through the initial kinks, we're going to expand that to a 5-bicycle system for fall of 2015. Through these 2 stages, our objective is really just to demonstrate a proof of the concept of a stationless bike share, that it's something that will work on the University of Maryland campus and that students will benefit from. Now, throughout this process, as all of the teams here have, we've faced a couple of challenges. Our first challenge was changing the focus of our project while still staying true to our original goals of elevating the profile of bicyclists on campus. Additionally, once we had our new project, mobilizing the team to effectively move forward in research and product development became difficult, partially as a result of the challenges of individual time management and the coordination necessary in order to get lots of people with limited time to work together in an efficient manner. Now, our recommendation to the freshmen in the room to get through challenges such as the ones that we faced is to focus on your organization. That's what has really pulled us through. As Tim was demonstrating earlier, we have an org chart that kind of replicates what you would see in a professional engineering firm. And it works very well for our team because it breaks up the necessary tasks and holds each person accountable. So find an organization that works for your team and stick to it because that's really going to pull you through. Additionally, we recommend that you apply for grants because it's wonderful to have the money that you need in order to move forward when you need it and to not have to wait for it. Finally, spend time together because a happy team is a successful team. Another thing we've learned throughout the years is that we wouldn't be here without the help of many people along the way. There are several technical consultants that we would really like to thank for all of their help this semester in particular, and we would also like to thank our librarian, Ms. Robin Dassler, the Gemstone staff, and our mentor, Dr. Newcomb, for all of their support throughout this entire process. Finally, I invite you to pull out your phones and take a look at our website. You can visit teambikes.me and play with it for yourself. Any questions?
So are there any questions? Yes.
I like the prototype. I think it's really cool. Have you guys given any thought to like power systems? Like, are you planning on using a battery or something that's rechargeable?
Sure. So the question was, how are we going to power the system? Is that pretty much it? So that would be...
So currently, we're just trying to use a battery. Maybe in the future, we could look at more greener solutions, like solar panels or something. But currently, for now, we're just looking at batteries.
Yes. You want the green?
Do you have an enforcement policy in the event people do not return the bikes?
Okay, so the question is, if someone doesn't return the bike, is there an enforcement policy? So, I can take that one. Essentially, when you sign up for the bike share, you would sign pretty much a liability form, as you would see if for any other activities that you might injure yourself. But this would be like the injury of the bike. So if someone steals it, since we have that last user on the recorded data, we'd be able to find them and ask them like, hey, where's this bike? Or we're going to charge you for it because you haven't returned it in a set amount of time. Does that answer your question? Is there anyone else? Yes.
You guys mentioned that you did 3D printed lock systems. What kind of testing did you do on those? And like, how do you plan on relating those tests on a plastic mold to the metal mold? You guys said you want to make a relationship, but I didn't go too much in depth on it.
Sure. So the question was, how are we going to test our lock design and test lock designs in general? So Josh can take that question.
So the 3D prototypes are more for the proof of concept to see if the design itself as a shape will work to open and close, lock around fixtures, and fit. We'll do strength testing once we've picked one. Then we'll actually machine it out of metal as then we would the full scale lock, and we'll strength test those. Answer the question?
Yeah, thank you.
Okay. The black.
So for the access control part, if the NFC were to malfunction, is there any backup ways for a person to obtain his bike?
The question is, if the NFC malfunctions, is there any way to obtain access to the bike? So that would be if someone doesn't necessarily, like an outside user, is that like an outside user that's not part of the system?
like if like the NFC control like somehow like does not function to unlock bikes.
Okay, so, you guys understand?
If the access control, like the NFC module malfunctions, then there will be no way to access the bike, but that wouldn't be really a problem per se, because that means that no one will be able to get the bike. So we can have someone out there to fix it.
So in your liability agreement, did you have any, like statements regarding like the like for example, if they get into an accident with another person? So like, maybe if someone got hit by a bike, and they got transmission.
Sure, so the question is, with the liability agreement, is there any access of use of the bike? Alright, so we hadn't really thought into depth about the liability of the person on the bike riding it. Essentially, hopefully prefer that they know how to ride a bike to begin with. It might not be sponsored by the university per se, so it might not be the same policy as getting hit by a bus, so no precaution in that regards, but it's a good question. Is there anyone else? Yes?
Have you given any thought to environmental concerns such as extreme heat, snow, rain, if you have these components like batteries or Arduinos in the system?
The question is pretty much weatherproofing the devices for all seasons.
The locks themselves are going to have housing in order to store all the electronics. Those will be watertight and possibly insulated. We haven't quite gotten into that much depth yet. We have one possible option here, where it just houses everything inside and keeps users out of it and keeps the weather from it to try to preserve the life of the lock.
And also kind of to answer that question again, the fleet of bikes will actually be shrunken during the winter months just because the sheer number of people will probably reduce because of the weather. Are there any other questions? Yes, you?
Do you have any sort of anti-thief features, such as if either A, the lock is broken with a powerful tool, or B, someone blocks it to the air and later just takes the bike away?
Sure, so the question is if someone doesn't properly lock the bike or if someone tries to steal the bike, is there any anti-theft deterrence?
So to answer your question, we're looking into the process of figuring out whether or not someone actually locks the bike to an actual lock. So we're thinking of having some sort of sensor or something that can tell whether or not it's actually being locked. And we're having different phases, so like there'll be like 3 stages of the locking process that need to be acquired for it to be locked properly. And if not, there'll be some signal sent back to the main receiver saying it's not locked properly, and we'll know.
So last question. Fight for it.
How is the reliability of the Zigbee system? Because with, is it like a Wi-Fi network is what you compared it to, but then we all know how reliable and secure it can be, and the fact that it goes down every 10 minutes.
Sure, so the question is how reliable is the Zigbee system? And Luke is the Zigbee guy, so he can answer that question.
So one of the problems with the Wi-Fi network is it's at a higher frequency, 2.4 gigahertz, which doesn't extend as far, and especially when you have more users, it falls back because of the more traffic. With our network, we're setting it up at a lower frequency, 900 megahertz, so it can reach farther, and the amount of data that's being transmitted over it is smaller. So we decide how many routers go out, such that we will always be able to be in constant communication with each bike.
So thank you very much for the questions.